Good morning. It's 3:53 a.m. and I know it's early, but I woke up around 2 something and was wide awake, and I thought about the atmosphere, the sunset, the sunrise, the reddish brown color in the sky talks of maybe some dust storm or something coming. But really, and a lot of people are having effects. If they stay outside, they'll get itchy throats. It'd be hard to breathe, and everything's heating up, you all. It is. So, but specifically, that's what I woke up thinking about. My throat's been itchy. I've been spending too much time outside within the past few weeks. And then I got to thinking about one thing led to another. Okay, one thing led to another. Let me put this over here. There may not be anyone on here. Hello, Adrian Barker. Hello, Tricia. Oh, that's so welcome. Welcome for being on here. Thank you for coming on here. This is super, super early, and it's not a time that I would normally, Sarah Honey. Yeah, we're going to address all of this, the redness of the sky, the reddish brown. I'll try, but we know that we hear a lot about Nibiru. Planet X is coming, that it has the iron oxide dust that is surrounding it. I'm trying to get this, see if we can get this chat rate. So we ain't got no zero chat rate. Zero chat rate. Isn't that strange? How do you say that you have a chat rate of 0 when you have people in here? And they only shows, look, watch this, only 7 people viewing, and we got 45 viewers. Okay. This is a really interesting. Good morning. Yeah. So I put together this image right here that you see behind me. No, I don't. I'm sitting here staring at the chat rate. That's not funny. It really isn't. I'm sitting here looking at why that chat rate ain't doing anything but the image behind me. Yeah. And you notice I've got some lightning strikes behind me. I got this, one of the images of Planet X that is out there, Nibiru, the Destroyer, Herbaluculus, I can't even say it, Wormwood, all of it. So, oh, I'm doing fine. I'm doing great. Planet X is, okay. Okay, now the chat rate shows up, okay. Yeah, you all. Please give this video a thumbs up. So we got this, we got this right here. We know that we have, all around the world, we have these reddish brown skies at sunrise. They start spraying the sky around sunrise before it rises. They spray the sky before it sets, while the sun is up there in the sky. Okay, they do. But I found something else that was interesting. Do I have this on me? I want to make sure I do. Come over here. Okay, we're here. 50 watching. Yeah, we got some people watching. We do. 59 people. I'm going to get right to it because I don't want to be on here. Maybe I might want to go back to sleep. I might. You never know. So I did a little researching. I did. So, just one moment. I know my face is getting a little, I got a window screen open. So we're looking at the Center for Science Education. Nitric oxide is a colorless, flammable gas with a slight odor. Nitrogen dioxide is a deep red-orange gas that is poisonous but not flammable. It, along with aerosols, is responsible for the reddish-brown color of smog. At high concentrations, it is highly toxic, and it can cause serious lung damage nitrogen dioxide is a strong oxidizing agent. Okay, look. Nitrogen oxide are a mixture of gases is composed of nitrogen and oxygen, two of the most toxicologically significant nitrogen oxides are nitric acid, nitrogen dioxide. Both are non-flammable and colorless to brown at room temperature. Sharp, sweet-smelling gas. Okay, so we got this. Yeah, we got nitrogen oxides in Queensland. Okay, we got smog and stuff like that. And we are seeing it. We're seeing it. I thought it was really interesting that, you know, nitrogen oxide and nitrogen dioxide makes the sky look like that too. Okay, it does. And it is hard. It's hard to breathe at times. Yesterday was a very difficult day for me outside. And even though I'm like 55, I normally don't have any trouble breathing, although I was like helping my daughter put the last 10 loads of ricks of wood in our shed, stacking it up, doing the wheelbarrow. I had to sit down so many times. The heat was so excessive. It was very hard to breathe. I felt like my lungs were starting to hurt. I did, and I don't smoke or any of that kind of stuff. I don't. But when we look up at the sky, we're seeing this right here. Okay, we are. And somebody made a strange comment during the live stream yesterday. They said, Gina, have you smelt the ozone? It was when I was outside filming in my yard. I said, no, I've been too busy smelling the roses. Have you smelt the ozone? Okay, this is purportedly in the ozone too. Okay, it is too much nitrogen oxide, too much nitrogen dioxide. Let me come over here, I want to get into that too, because there's something so much more to all of this. There is. So let's push this back to me. Okay, so much more to it. Let me get this on here. So then, you know, you can look at, we are going to look at, let me tell you what, we are going to look at, I was looking up nitrogen dioxide and, all that nitrogen stuff. Then I ended up on Star Trek. There was an episode where this life form on Star Trek released nitrogen. We're going to see what it released, because this is really interesting too. Let me see if I can get it over here. It infected nanites. Okay, nitrogen oxide, frequently abbreviated as NOx. Okay, NOx refers to one or more nitrogen, oxygen, more gaseous nitrogen oxygen compounds that are toxic to many species, including humans. Okay, including humans, when concentrated in sufficient quantities. In 2,366 nanites that had infected the computer core of the Enterprise released nitrogen dioxide onto the bridge of that starship in retaliation for Paul Stubbs' use of gamma radiation to destroy several of the nanites. You may say, Gina, what does this have to do with the reddish-brown sky? Well, we just read that. We did. We just read about, of course, we got the Nibiru. Okay, we got that. And look at this. Look at this. Science madness. See, now here they're talking about the effects of NO2, which is a combination of nitrogen dioxide. Look, it's a deep irritant. It can produce pulmonary edema and fatality if inhaled in high concentrations. It may produce a cough, hemoptysis, dyspnea, and chest pain. Higher concentrations, okay, higher concentrations. And you have here on the nanites releasing nitrogen oxide. Okay, they're releasing nitrogen oxide. By the way, this NOx, if you haven't noticed, NOx, let me put this back to me. This is also what is out there, NOx. Watch this. Standards. We have nitrogen oxide control regulations, environmental protection agencies. Okay, we do. NOx right here. Okay, we have that. And it's all over the place, and they're getting ready to implement it again, big time. They're going to hold, but they're saying it's from fossil fuels and all this kind of stuff. Okay, that's what they're saying it's from. Let me pop back over here, you all. It's going to take me a while because I don't have this pulled up on my phone to read your comments. Perhaps I should. Let me see if I can pull myself up on here, to see if I can see any comments without having to come back over here. Okay, I can, you all. This is it's somewhat important. Okay, it is. Okay, I've got you all in the live chat. That's good. So where were we at? We was talking about these nanites that were released. Okay, we were. And we have these treaties. We do. We have this these standards, these regulations that they are getting ready to implement even more so. Let me see what else I got up. We have Planet X, classified information, all of this kind of stuff. All right, nitrogen oxide, production of nitrogen oxide by lightning. Come on, you all, let's talk about this. By lightning. So we got this right here. Look at this, you all. I want you to look at this. We're going to look at this because I woke up at 2 in the morning, so they better have woke me up to give me something good to say, to share with you all. Yeah, otherwise I would not have got up out of that bed. NASA's top story, surprise lightning has a big effect on the Earth's surface. The amounts of ozone, you all, this better be on here. The amounts of ozone and nitrogen oxides created by lightning surpass those generated by human activities in that level of atmosphere. Typically, over the U.S., fossil fuel burning is the main cause of nitrogen oxides. NOx, see, we got these standards also. Look over here. We got wherever these standards are right here. The I got to get over here, you all, because we just looked at it. We got it. So where we at, you all? We got to get over here. The main cause of nitrogen oxide, which is NOx, which lead to the formation of ozone near the Earth's surface. Okay, we got that. Let's hop right over here to the something else, you all. We're going to look at something else. You keep looking at me right now. I get myself in trouble for this. I really do, and I'm not just saying it. I mean it. We're talking about that kind of stuff. We are. And now we got all this going on. Okay, yeah, they got their data. They got their databases up. In fact, this is one of the reasons they got their data up. We got this, looking over here at these lightning strikes. Now, NASA just admitted that this increases, it depletes the ozone worse than anything that we're doing, okay? Anything that we're doing, okay? We got these lightning strikes on there. Great, this is fine, lovely. It's great. It's fine and dandy. The amounts of ozone and nitrogen oxides created by lightning surpass those generated by human activities in the level of the atmosphere, in that level. Okay, we got it. We got it. Okay, now, so voila, we just come on over here, you all. We can do this. We can come right over here too. Can I do this for you all? I'm going to do this for you all because we need to look at this also. It's very important. Let's come over here to this. We're talking about the reddish brown and stuff and all of that nitrogen oxide, dioxide, and all this kind of stuff. Yeah, we got it all going. We do. And we're going to talk about it because I woke up early in the morning, so we got something to talk about. Let's give them something to talk about, like that song. So this is March the 19th of 2003. So they have been studying lightning, a big effect on atmospheric chemistry. Yes, I say it does. We got it going on. You got the data. You got data going all over the place. Okay, you do. So it has a big effect. So scientists were surprised to learn summer lightning over the U.S. significantly increases the regional ozone. Isn't that something? Other gases that affect air chemistry is 3 to 8 miles above Earth's surface, the amounts of ozone and nitrogen oxides created by lightning surpass those generated by human activities in that level of the atmosphere, you all. Typically over the U.S., the fossil fuel burning is the main cause of nitrogen oxides, which leads to the formation of ozone near the surface. Let me put myself on here too. In the free troposphere. Okay, look. So during the summer months, lightning activity increases the NOx, but by as much as 90%, and ozone by more than 30%. Oh, but this time, they've been doing this data right here. Yeah, well, they've been doing the data, so we're going to look at it. We are going to look at it. Renzi Zhang of Texas A&M University, the lead author of a paper recently appeared in the Proceedings of the National Academy of Scientists, suggests that lightning has distinct impacts on air chemistry over the U.S. human activities dominate the creation of these gases near the Earth's surface, but lightning plays a bigger role in the free troposphere. Depending on where the ozone resides, it can protect or harm life on Earth. Most ozone resides in the stratosphere, a layer of atmosphere between 8 and 25 miles high, where it shields life on Earth from the sun's harmful ultraviolet radiation. Okay, as you know, it's really hot and it's hard to breathe, and this lightning is not helping reduce the carbon footprint on Earth, kind of like that too. So as a result, the ozone is a harmful pollutant that causes damage to the lung tissue and plants. In the troposphere, surface to 8 miles high, the ozone also is a radioactive gas that affects the climate. About 77 million lightning bolts annually strike the U.S. I'd say that number has increased dramatically. I really would say that it has. Let's see this, we can look back at it. It has 77 million lightning bolts strike the U.S. Measurements before after lightning strikes have confirmed that the generation of nitrogen oxides in the atmosphere. Ironically, over the United States, lightning accounts for only about 5% of the total U.S. nitrogen oxide annual emissions and about 14% of the total emissions. Although the largest source of NOx over the United States is fossil fuel burning, lightning still plays a dominant role in influencing the regional chemistry. But the explanation is NOx from fossil fuel burning is released close to the surface. Okay, lightning directly releases it through the entire troposphere. The lightning source over North America for NOx is sufficiently large so that it has implications on free troposphere over other parts of the world, most notably Europe, which is downwind of the U.S. given the prevailing westerly flow in the northern hemisphere. NASA-funded research. Okay, primary causes of changes in Earth system, including man-made natural causes. So we've got this U.S. human lightning sources contribute to air pollution in the lower and upper troposphere. So this is the paper about this lightning right here. And we have the color of, let's find the color of this nitrogen oxide and stuff. Yeah, here we go, right here, reddish. Are we over here? Reddish brown. Nitrogen dioxide is a deep red-orange gas. Okay. But it's highly toxic, and it looks like smog. Okay, it does. It looks like smog. Let me see if I got any pictures of it up. I'm not done yet either. I'm not. I want to show this. Well, this is its chemical thing right here with the periodic table. Of course, they give this color right there. Some cities are full of that. I'm not saying they're not. But to find an article where they're saying that lightning helps contribute to that. Okay, I believe it. Okay, I do believe it. I get in trouble for the lightning too. But it was talking about the nanites on this Star Trek episode right here. They were a life form, okay, and I had clicked into the evolution right here. Are you going to follow me? Yes. What did something high temperatures of a Nibiru and stuff like this? Okay. So let's look at this. This is a different thing. So we're talking about gamma bursts right here. Dr. Stubbs, they're talking about they're talking about a strain of this right here, whatever that is. I don't know what it is. This thing right here. And that is a life form. Okay, it's a life form. It cannot, they can't exterminate something that may or may not be intelligent. So they don't want to, this might be intelligent, this right here thing. So they don't want to, because it is a collective intelligence working together. Let's look at this. Gamma bursts. Let's want to look at gamma bursts. Data and LaForge are trying low gamma bursts in an effort to slow down the productivity of the nanites. But Stubbs says, ask if they've tried a high-level charge, but Data replies, a high-level charge will kill them. So they're taking out their energy weapon and firing on the core with high-intensity gamma radiation. Okay. So they don't want to kill them, you all. They don't want to kill us. So we got high-intensity gamma radiation. Okay, let's talk about the sun. Can we look at the sun now? Gamma radiation from the sun. Yeah. Gamma rays from the sun right here. We got these. The sun is spitting out strange patterns of gamma rays. Okay, you got the sun spitting out strange pattern of gamma rays right here. Let's see what that looks like. I don't know what it would look like. Okay, no, fine, get it out there. Okay, we've seen this image before. So this right here, coming from the sun, we're having a whole lot of solar bursts. We are solar flares and coming from the sun. But according to, and we got the brown skies, we got the brown skies. But if truly there was like an energy weapon coming from the sun or from satellites above or something else, firing gamma radiation to the Earth, well, we got a lot of this nitrogen stuff right here in our atmosphere. We do. We got talk of the wormwood right here, Planet X. That could be causing this also, the brown in the sky. Okay, the brown in the sky. But we know from looking at this, if we can get over here to the picture, that this is also a deep red-orange gas that is poisonous, but in high concentrations, it's highly toxic. It can cause serious lung damage. So if you're outside and the sky looks like that, it's hard to breathe. It says what do they call that? A ozone health day or something like that. Don't go outside because it's hard to breathe. Because you got all this stuff in the air and it's hard to breathe. It is. It's hard to breathe. Okay, we got that. We got these lightning, which really it increases ozone, okay, and other gases. Oh my goodness, you all. So this is it increases the layer by as much as 90%. Okay, it does. And we have in the Star Trek, they got these nanites that infected the computer core with nitrogen oxide onto the bridge. So in retaliation for use of the gamma radiation, they wanted to use this to destroy the nanites. Could the nanites be responsible for what's happening? Really, can they be responsible? Are there nanites being released in the atmosphere also? And they're in this doing all of this kind of stuff, you all. I know this is a wild thing, you all, but they got these energy weapons right here on the Star Trek. And I think Star Trek talks about a lot of things, They even use technology that's out there that we haven't seen for a long time. Okay, but they don't want to do this. Look. They call them the tiny Lilliputians. They wonder how much longer they will have to wait because they infected the computer. The nanites are soon spreading through the whole ship, and suddenly they smell a change in the air. Okay, because of the nitrogen oxide or whatever it is they released. The bridge is being flooded with toxic levels of nitrogen oxide, which is also in our atmosphere. It is, and you know the colors of the two that are being showed up. Okay, you know what it looks like. Riker manually overrides the air handler and removes the toxic gas, and the bridge continues to suffer malfunctions with lights flashing on and off, consoles deactivating. So they got the nanites. All the nanites in the upper core have been killed. They killed the nanites. They killed a life form, you all. So yeah, so that's this is all interesting. NASA talking about how this lightning is really making the ozone layer really bad too. Okay, we got that right there. We got this is what it looks like: smog, reddish brown. We got the 12th planet over here. We got the Zechariah Stitchin. Let's just hypothetically, you all, let's just the tail of debris tail of Planet X. Planet X. Let's see what that would bring up. Yeah. So we'll come over here and look at this. Red dust. First you get the red dust. The devastating. Let's go over here. I can't go to Zeta because it's not recommended, you all. It's not. The devastating tail. What arrives at the Earth during the pole shift and what does not. The red dust comes first. Early evidence of red dust in 2003. That's strange since NASA had this lightning thing in 2003. And it increases the nitrogen oxides in the atmosphere, which nitrogen oxide is a deep reddish orange thing. I don't even know what that is, you all. I don't. So this is a goose chase, you all. It is. We've got the gamma rays that can, I guess, maybe kill the nitrogen oxide in the air. Planet X. I'm not really looking at the comments. Yeah, we got CERN also. We do. Where are we at, you all? I wanted to find the debris tail because that's what they said. It does come first. We can't go into Zeta. It's the 14 million miles, the Planet X debris tail with dust and nitrogen. Is it nitrogen, you all, that it has? Iron oxide. It has iron oxide. That's what it has. Iron oxide is what it has in it. I knew it was one of those oxides right here, so we can look at this. They say that that is causing the reddish color of the sky too. So is it iron oxide? Even though they have said they found samples of iron oxide, they did, found samples of iron oxide in the, okay, iron oxide in the atmosphere. Okay. We got this, look. The unexpected atmosphere effect on the iron oxide growth by laser floating zone method. Why you want to do laser floating zone effort, you all? I don't even know where we're at. Oxygen particle pressure influences the crystallization of magnetite by laser floating zone method, LFZ. Fibers present a conductor core. I'm probably not supposed to be on that. I don't know what that is. Well, they talked about the atmospheric pressure. They did. iron oxide. What's it look like in the atmosphere? Aerosols. Okay, so now we got, look at this. Anthropogenic iron oxide aerosols enhance the atmospheric heating. Okay, but where do they come from, you all? We know that something flies above in the sky. We do. It, I think I hear the wind picking up the iron oxide in the air. And that's what it looks like right here. The dust and the dust storms. Okay, we got these dust storms. The Sahara dust storm. Let's type that in. Dust storms. Of course, and with iron oxide. There we got it, you all. Let's put that in there. The Sahara dust storms. Interesting fact. Well, we can't even get anything on here. All we know that the sky turned red in Nigeria. Let's see what happened there. Why, my goodness gracious, you all. That is May the 7th of 2020. That's just like just a few years ago. After the huge sandstorm in Niger, the sky turned red. And the people who likened it to the apocalypse was in a great rush. A big sandstorm struck Niamey, the West African country, with iron oxide, which gives the red color to the sand in a short period of time. The sky turned into red color with the mixing of iron oxide in the atmosphere. So what happens really if you mix iron oxide with this other stuff? Okay, iron oxide and nitrogen oxide. Let's see this. Iron oxide. I don't know what would happen. I don't know. It's they've shown to play an unprecedented variety in the biological systems. I wanted to know what happens with them if they mix together. I'm not a physicist, and I don't like the periodic table. I don't unravel it. Okay, they got nanoparticles. Okay, nanoparticles and stuff. Green synthesis, characterization applications, blooming of harmful. Okay. Currently, iron oxide nanoparticles are used to reduce nitrogen and phosphorus and to reduce the blooming of harmful algae. Okay, that's fine. That's fine. Okay. Colorless gas, mild odor, sweet taste, anesthetic. Let's get out of that, you all. We're going to talk about the sky turned red. Look like the apocalypse. There. Yeah. So this is good. This is really good that you're all in there able to chat with one another while I'm just looking at this. This is great. I hope everybody's behaving. So look, they have not encountered such a big storm before. So they did liken it to the apocalypse. Viral photos show a huge sand tsunami. On the other hand, it's reported that the inhalation of iron oxide fumes could cause fever, chills, breathing difficulties, and permanent damage to the eyes. And the people were asked not to leave their homes during the sandstorm. Okay, because you don't want to be outside during it, because this is what could happen. You have to ask yourself, how on earth can that get in the sky like that? How can it? Yeah. Let's look at that. So, we've got that Niger, but yeah, there's something going on. There really is. Like, now we got this, the sky turns red in China. Let's see when they had the red sky. Okay, they had a red, scary sky blankets the Chinese city on August of 2021. Turns red in China. I don't want to push that button. Because I could get trouble. Let me see. Let me see this. Let's see if we can enlarge. Let's see the sky in China. That does look kind of apocalyptic. It really does. And they had it again in China a few days ago. Okay. Well, this happened also back then. So let's look at that. So we got red China. So we got this too. The effects of Nibiru complex. Let's see what this happens, you all, because we got red sky. I mean, there could be a number of things that cause it. I want to get this over here. If this thing is taking too long, it may not even want to go there. Whatever this is. Signs of the time. The big picture the media will not give you. The effects of the Nibiru complex. Rof Mir. Oh, updated on August of 2011. It will be at its closest. Excuse me. Follow up. Earth's displacement. So, Nibiru's arrival. The inner part of our solar system in March of 2003, which just so happens to be in this article, March of 2003. Where are we at? I gotta find the one that we were in. Yeah, so look at this. So Nibiru's arrival into our solar system in March of 2003 was picked up by the seismographs all over the world. Oh, this is a very long thing, and I'm not going to go into it, but yeah. The Earth's increasing wobble of the spin of this axis resulted in extreme weather. Temperatures, weather out of harmony. Dangerous maelstroms, Arctic sea ice. Catastrophic fall in global food production. What are they talking about? In 2007, by 2009, the North Pole was pushed consistently away from the sun. Around 2010, the effect of the Earth's TRAPPIST constellation reached a new phase, and the wobble was rattling you. I don't remember this again. The effect of Nibiru on the plates, stretching the plates, sinkholes, earthquake, volcanic activity, boom in the air, underground rumbles. I've not heard any of this. Stinking methanol, tungsten event, magnetic field, anomalies in the moon, abaloism, fireballs, meteor, electro satellites rotating out of position, crashing, massive power blackouts, train aviation accidents, biological compasses fail, hydrocarbon, all of this kind of stuff, increasing wobble of the earth. Okay, so it can cause all of that, y'all. I'm not one for Nibiru. I'm not. I don't really get into it, but there's people that solely focus on Nibiru, and got this thing, I'll twist it over here, Nibiru and Planet X. But really, with the iron oxide dust, about time for me to get off of here, you all, with my throat getting like this. The iron oxide dust, and they're saying it comes from Nibiru. In the air, and you have this dust cloud that comes every year, and they say it's from the Sahara plume, or the Sahara dust storms. You all, let's look at this. The Sahara dust storm. Let's push this over here. Let's see. Let's see if they're going to talk about that. Dust from the Sahara. Okay, look at this. Is on its way in the deep south. A plume of dust from the Sahara Desert will move into the Gulf of Mexico, southern plains, and southeast this weekend, into the next week, and it will push into the Gulf of Mexico. Okay, let's see what that looks like, you all, because we can look at that. And let's see what he has to say.
The air seemed maybe a little dusty to you. It kind of did to me, actually, this morning. I just thought about that. Dust all the way from the Sahara Desert in Africa is in the skies above Alabama. WSFA First Alert meteorologist Tyler Seabury is also in the studio. Tyler, what exactly does this mean for us?
Yeah, that may sound, if I just left it off right there and said dust from Africa is in the skies in Alabama, and that was it. That's all I said. Boy, that would be a little odd to leave it at that. But this is actually a phenomenon that happens every single year. Year after year, dust from the Sahara Desert gets kicked up in May, June, July, and August, and courtesy of strong winds, gets
Can you all hear that?
lofted into the air. And when things get lofted into the air and they're very light and tiny in size, like dust particles and particulate matter, well, the wind can then push it. So here's your current Saharan dust concentration. A little bit in our skies now, but a plume of heavier concentrations getting ready to push right across the Atlantic Ocean. And here is Saturday morning. Notice a rather thick concentration where you get the yellows, especially in the Caribbean, getting into the Gulf of Mexico. So the concentration we have out there now is actually going to get a little higher. Look what happens by the weekend. This is now Sunday afternoon. The Gulf of Mexico encompassed by an area of enhanced dust matter. And then that continues into early next week. That spreads inland into parts of Texas, Louisiana, Mississippi, Alabama, Florida, and Georgia. So this weekend into next week, the dust concentration, this is not going to be a ridiculously high amount of dust, but there will be noticeable impacts from this. It happens every year as the dust gets kicked up and sent across the Atlantic Ocean. And every 3 to 5 days, we'll be tracking a plume of dust. That's just normal. Every year, this time of year, May to August, every 3 to 5 days, an enhanced plume of dust will get picked up and shoved across the Atlantic Ocean. And usually it ends up in the Gulf of Mexico in the United States, especially the southeastern United States. But it can, something good here, hinder tropical development. So we like when this happens, but if it's thick enough, it can reduce visibility and air quality and cause breathing, respiratory problems. But Bethany, with this particular outbreak of dust, I don't expect it to be problematic enough to cause any health-related concerns.
Okay, so yeah, they said that, and I thought in this dust right here it had iron oxide in it. Is that what happened with the Nibiru? Okay, because I think it probably did. Look at this, the Saharan dust. 100-degree heat index will greet your South Floridans. Isn't that very nice, you all? 100 degrees will greet the South Floridans. Oh my goodness. Yeah. So I don't buy it either. I really don't buy it. I don't. Let's click into it. The heat index, May the 21st, which is yesterday, will greet South Floridans this weekend. Get ready for slight hazy and hue-altered sunrises and sunsets. Well, what's altering them all throughout every other day of the year? Why is this day with the Sahara, why is that any different than what we have been seeing every single day? Red sunrise, red sunsets. What's the difference? Now they're just saying the dust storm now? See, there's something more to this. There really is. There is no difference, okay? It happens every day, except now we got this thing coming around. And they did say that Nibiru has an elongated orbit. Okay, that's what they said. It's probably the first hot and humid weekend of the season. The Saharan dust, known as the Sahara layer, starts about 1 mile above the Earth's surface and is between 2.5 miles thick. That is very, very thick. 2.5 miles thick. It's common in May. And it's probably a bit earlier than normal. Well, why is it a bit earlier than normal? Okay, you have to ask yourself, why would this be a little bit earlier than normal? The air quality is moderate. It can lead to air quality that is not as good. It can also lead to sunrises and sunsets that are not as good, depending on your point of view. And you don't get as much orange, red, and purple as the sunrises and sunsets are not affected by the dust. Why are they not affected by the dust? Okay, I don't understand that, you all. But if it's it doesn't make sense. So they're tracking over the Atlantic Ocean, and the winds will come from the southeast. High temperatures should be around 90 on Saturday, 80s on Saturday, whatever. Humidity will be high. It's going to be hot. They said it's going to be so hot. Well, what happens if we were to look at Google Earth? Could we see it? on there? Could we see it on Google Earth? Because I'm not seeing it right now. Really, I'm not. Where is it at on Google Earth? Because I really can't see the dust storm. Do you see it? Because I'm not seeing it. Why? It should already be on here somewhere, unless it's dissipated. It really should. We can just spin this thing around. If I can even get to it, you all. It's hard to navigate this silly thing. Okay, I don't see it. I don't see it anywhere on here. And that's the Google Earth. I wonder if we see it on the GOES satellite. Imagery. Let's see. Let's go to the full disc right here to see if we can see anything on here. Any dust or anything. That's too large, I can't see it right here. Let's make this a little bit small. I don't see any dust. Well, if I don't know what they got going on. This is all dark. It's because it's dark right now, Gina, where you're at. You're not going to see anything. I'm not going to see it, you all. We don't need to go there. We don't. Yeah. You got the Oort clouds. So yeah, we got the Saharan dust. Let me get this out. Yeah, I got to close this all on here. We can look at the Oort cloud. Look at this. The Oort cloud might contain billions or even trillions of objects. Home of comets because the orbits of long-period comets are extremely long. The Oort cloud is the source of most of those comets. Oh, okay, that's great. It's a theoretical concept of a cloud, predominantly icy planetesimals, purposed to surround the sun. A giant spherical shell surrounding the sun. That's interesting. It's like a big thick bubble around our solar system. What is the Oort cloud? Okay, yeah, we're on here, you all. That's really interesting. Wait a minute. So we had a black cloud. Is an Oort cloud a black cloud? Oh no. So this is the Oort. This did not want me to go over here to this. You said, is the Oort cloud a black cloud? I've got this pushed to the screen, and it did not want me to go over here. So it surrounds the sun or some. Hey, you look like that's when we see this halo around the sun. Remember, you look up in the sky and you see that halo around the sun. Let's see that halo around the sun. Right here. So if this right here, is that an Oort cloud around the sun? Because this is what we've been seeing recently. All of this right here, all around the sun. An Oort cloud. Wow, you all look at that. I seen it in Hawaii too when I was, not Hawaii, in Cancun when I was there a few years ago, an Oort cloud. Whoever put that in there, thank you, because I've not heard of an Oort cloud. I haven't. Look at this, this right here, effect. See how it looks like this? It can also be seen as the sun is rising on the time-lapse videos in Hawaii too. It looks like something like this in this lens flare. It does. It looks like that in the lens flare with the sun rising. So the Oort cloud, that's really interesting. It's a spherical cloud of particles. All right. A giant spherical sphere. What? This is really strange. What on earth is this, you all? I don't know what that is. That's something else. Knowledge conquered fear. That's okay. So we went all over the place, you all. We really have, and I have no idea how long I've even been on here. I'm trying to make myself... Oh, it's 4:44 a.m. I think that's wonderful. That's what it says right here on my thing. I looked down, 4:44 a.m., 5. I got to take a picture of this. I'm going to do a screenshot of this. This looks pretty cool, you all, so we can see the screenshot. Look at this. Look at the screenshot. When I look down there, it's 4:44 a.m. on May the 22nd of 2022. That's great, you all. We've been on here for 50 minutes and 29 seconds. That's great. I like that, 444. Gina, you got to get it together. You do. That's right, 144A. That's great. So, this is back to me. Okay, it is. So the Oort cloud is, let me see, is an Oort cloud an intelligent cloud? Cloud a... It's just icy. That's all it is. Oh my goodness. Is it possible there is something intercepting our signals? Radio telescopes get radio signals. Only way to appear natural and not intelligent. We can get an imagery of wavelengths. We know that the Oort cloud isn't opaque to them. The Oort cloud is our own solar system's huge comet repository, which is to begin about 0.8 light years from the sun. No, I don't think we're the only intelligent species in our galaxy. I don't think we are. Okay, let's look at this, you all. We got to look at that. Look at that, you all. Since the Wiki fandom has this, I want to apologize that you were on here looking at Gina, and she's got this pretty graphics behind her, and we going all over the place, you all. Well, it's early in the morning. I woke up at 2 o'clock in the morning. I thought, well, that's fine. I'm kind of getting a little lightheaded, but we ran into the Oort cloud. Somebody mentioned that in the live stream, so we can look at the Oort cloud. That's right. Look at this. Oort cloud. Why would they write an Oort cloud in here? So we can look at this. This is a thread. Thread name was given to a voracious, non-sentient organism inhabited the Oort cloud of the Ruckbat system. Its appearance was a thin, silvery threads that periodically rained down on the planet. Their thread was mycorrhizal spore that consumed any organic matter it could find, but it was deterred by metal, plastic, and rock, and killed by water, cold, and fire. Why do they got the Oort cloud in here? Let's see what they wrote about it. It was a nebulous asteroid belt in the Sagittarian sector and the sixth of its kind discovered by this team. The one in the Ruckbat system contained the voracious organism known as the thread. Particles of this cloud, including thread, were dragged by the red star into an orbit. Oh, okay. So the Oort... They want to arrive at the Oort cloud and destroy the red star. What was the red star? Is that Nibiru? It was a planet that was attracted a few million years ago. Its orbit was almost parabolic in shape. It was conjectured by Pern Cullinus. The orbit might fall into our sun. That's really interesting. Suitable for colonization. That's they might see spectacular meteor showers in about 8 years. When the cometary trail burst. Okay, I'm all over the place now. I can't get off of that wiki fandom, but I tell you what, it's making me I don't even know where this thing is opened up in here. I don't. 8 is the beginning, you all. We're not going to look at this Oort cloud, okay? We're not, because it sends me on a wild goose chase, okay? It really does. Yeah. So that's right. So if you're on, let's do this. We got this. This is really important. So that's lightning. NASA's paper 2003, and that just so happened in March of 2003. They had proof of some kind of Nibiru system or something that they had spotted. But then this right here, nitrogen oxide in the atmosphere above the Earth's surface in the free troposphere during summer months. Lightning activity increases the nitrogen oxide by as much as 90% and the ozone by more than 30%. Okay, this nitrogen, this lightning that you see right here. Okay, we got it. We got the solar system, planetary atmosphere, and all of that. I'm going to go. I really am. I want to thank you all for coming on here. I was all over the place. I really was, but something's changed. And the Sahara dust, it comes every year, and it causes harmful effects on you if you're outside trying to breathe it. Okay, it does. Yeah, that's okay, you all. So, yeah. I guess I'm missing the comments. Everybody's commenting in here. That's great. Yeah. Oh, you're so very welcome, Brittany, honey. Thank you all for coming on here. I don't think I've ever got on here in the wee hours of the morning before like this. But I did now. And there was people here awake, probably in another part of the world. Yeah. That's great. So I'm going to go, you all. There really is so much more going on, and I think there's lots of pieces to the puzzle. There really is lots of different variants out there concerning the reddish brown sky, sunset, and things being sprayed up there, and then the iron oxide dust every year coming, and they saying it's the Sahara dust. And the nanites who released nitrogen oxide or dioxide into the Star Trek computer, and them using gamma rays to kill them. Okay, we got the solar things coming. We got all this lightning that increases the nitrogen stuff. There's lots of stuff going on. There is. That's all right. Yes. So I'm going to go. And with that being said, hello, wherever you are in any part of the world. Hello, from my heart to yours. Love you. Have a wonderful rest of your morning. I think I might go back to sleep. You all really think because I got myself tired now. That's okay. Thank you for coming on here. Gaia Watcher, it's nice to know about the Oort cloud, and whoever mentioned it, thank you. I didn't really know. So that's really good. They also say that the sun is hollow and the Nibiru system is inside it. So I guess that's, yeah. Yeah, good night, everybody. Thank you. And thank you for keeping this a peaceful chat.